In this problem, you can see that f of x is an even function. For example, you have f of minus 1 is equal to f of 1. That means both minus 1 and 1 are mapped to the same element. Namely, in this case it is 0. Therefore, it is not a 1-1 function. And also observe that the denominator, it is obviously bigger than the numerator. Therefore, this is always less than or equal to 1. That means it can't take a value bigger than 1. So it cannot be onto also. Therefore, it is neither 1 1 nor onto. Let's look at the next one. In this problem, he said A is symmetric. So A transpose is A. B is Q symmetric. Therefore, B transpose is minus B. Now, you need to check whether the matrix AB minus BA is symmetric, Q symmetric, things like that. Let me go for the definition. So I want to check the whole transpose of this matrix. Now we have A plus B whole transpose is equal to A transpose plus B transpose. So using that, I see this as one matrix, this as one matrix. Of course, it is true even for minus or here. Therefore, I can write it as the first one's transpose minus second one's transpose. And now we have AB whole transpose is equal to B transpose into A transpose. So using that, I have it as B transpose A transpose minus A transpose B transpose. But B transpose is minus B, A transpose is A, minus A transpose is A, B transpose is minus B. So I am getting AB minus BA. So I observe that the transpose of this matrix, I am getting it as the same thing. So by definition it is a symmetric matrix. Let's go to next problem. Okay, in this problem, you see we have this property in determinants. We have, if I have a determinant like this, A1, A2, A3, U, V, W, and here I have X, Y, Z. I'll do one thing. Here instead of A2, A3, let me take B1, C1, B1, C1. And I have one more determinant A2, B2, C2, U, V, W, X, Y, Z. And in another one, I have A3, B3, C3, U, V, W, X, Y, Z. Then, if I add these things, I'll get the determinant A1 plus A2 plus A3, B1 plus B2 plus B3, C1 plus C2 plus C3, and here U, V, W, X, Y, Z. This is there. In matrices, we know that this, in determinants we have this property. So observe that when two rows are fixed, they are the same in all these determinants, and only when one row is varying, this row is varying, then you can see how I can add up all those determinants, keeping the constant fixed rows fixed and simply adding the elements of the row where the elements are varying. So observe that it is the same concept I have to apply over here. Observe that in every determinant over here, delta R, if you take whatever the R value is, as R is not there in the last two rows, these two rows are going to be fixed. Only the elements of the first row are going to vary. So when I add up all these determinants in the sum, you can see here these are the determinants, and this is the sum. In the sum, the fixed rows remain fixed, and wherever the elements are varying, only in that row the elements they get added up. So applying that story here, you can see that now sigma delta R is equal to 1 to n minus 1 is nothing but keeping the remaining two rows as they are, n by 2, n minus 1 A, n into n minus 1 by 2, n minus 1 whole square, n minus 1 into 3n plus 4 by 2. Okay, for fun, I adjust them, I'll write A here. So, all that you get is, in the first row, the elements they have to be added up. So here you'll get sigma R, and here you'll get sigma 2R minus 1, and here you'll get sigma 3r minus 2 you get. Okay, and now when I add that and add this, let me see what I am getting here. Observe that sigma is running from 1 to n minus 1. Now I am writing this summation over here. So I have this is equal to determinant sum to first n minus 1 natural numbers. So it will be n minus 1 into n by 2. And this is sum to first n odd numbers, n minus 1 odd numbers. So we know that it is n minus 1 whole square. And the second part, let me keep it as it is because we are going to observe that we don't need its simplification. And observe that this is n by 2 here and this is n into n minus 1 by 2. And this is n minus 1 and this is n minus 1 whole square. Now you can see that if I write the second column by first column, I mean this entry by this entry, this entry by this entry, you can see that everywhere it is the ratio is n minus 1 by n by 2 everywhere for the first pair and for the second pair, for the third pair. That means the columns are proportional. That means the value of the determinant is 0. As the determinant is 0, it means it is independent of both a and n. Okay, let's go to next problem. Now here in this problem, he said tangent of half the difference of two angles. Let me assume the angles are A and B. Their difference, half the difference, their tan is 1/3. The tangent of half the sum of angles. Sum of angles, half the tangent of the sum. So it is nothing but tan A minus B by 2 by cot C by 2 is equal to 1 by 3. This is cot C by 2 because we are in triangle. Now you can see that by Napier's analogy, that is tangent rule, LHS is nothing but A minus B by A plus B is equal to 1 by 3. Now I apply componendo and dividendo. So on the left hand side, denominator plus numerator by denominator minus numerator. Doing the same thing on the right hand side, it is 3 minus 1 by 3 plus 1. I am getting the ratio as 1:2. So 3, sorry, it is, I have to add actually. So it is 4 by 2. So it will be 2:1. It doesn't matter even if it is 1:2 because among the options you have only one there. But this is correct. I said it doesn't matter because he said difference there. So some other people may like to take that as B minus A. Still among the options you don't find any difficulty. Okay. So let's go to next problem. In this problem, he gave this is k and he said it is continuous. That means we have limit extends to pi. F of x is nothing but f of pi by the definition of continuity. Now f of pi is k is equal to limit extends to pi f of x, that is root of 2 plus cos x minus 1 by pi minus x whole square. Now we observe that it is 0 by 0 form, so I can apply L'Hopital's rule. I'll get limit extends to pi 1 by root x derivative I am writing 1 by 2 root x. So now I have to write its derivative, which is minus sin x, and for minus 1 the derivative is 0 by, for the denominator it is 2 into pi minus x, and then I have to write its derivative, which is minus 1. And now I observe that it is limit extends to pi 1 by 4 into root of 2 plus cos x into sin x by pi minus x. I want you to observe that for this part there is no problem, okay, and for that part the limit is nothing but 1 by 4 into, for this part again we apply L'Hopital's rule as it is 0 by 0 form. So I get cos x by minus 1. So this, after applying the limit, you can see that it is 1 again. So the answer is 1 by 4. Okay, let's go to next problem.